Alright, in this video we're going to do a couple examples where we solve some basic trigonometric equations. So the instructions here were asked to find all angles theta between 0 degrees and 180 degrees satisfying the equation. And the first equation we'll look at is sine of theta equals 0.4. Alright, so first off, I'm looking for all the angles between 0 degrees and 180 degrees. So they're asking for angles in degrees, so that tells me that I need to give my answers as degrees rather than radians, which is an important thing. If we have to use the calculator, we have to make sure it's in degree mode when we do that. Then I look at my equation. Sine of theta equals 0.4. Well, 0.4, that's not one of the numbers I recognize from the unit circle, right? The numbers I recognize from the unit circle, I'm talking about the terminal points. So those numbers are 1/2, root 2 over 2, root 3 over 2, 0, 1, or the negatives of any of those. 0.4 is not any of those numbers, which means to solve this equation, I'm not going to be able to use the unit circle. I'm going to have to use my calculator to do that. Right? If it had said sine of theta equals root 2 over 2, well, root 2 over 2, I know that's on the unit circle. Let me just use the unit circle to get my answer. Right? But when I have a number like this, 0.4, I got to use a calculator. All right, so sine of theta equals 0.4. If I talked about this on the last video that I did where I did some examples of solving right triangles and solving for angles. When I'm looking for theta, or if I'm looking for an angle that's inside the sine function, in order to do that, I need to use the inverse sine function. Or if it's cosine or tangent, whatever function I have to use the inverse of that function in order to do it. Now, to give you a quick explanation of why I have to use the inverse here, I'm solving for theta, right? But theta is inside the sine function. Right, so in order to cancel out the sine function, I have to use its inverse. So basically I do sine inverse on both sides of the equation. Right, so I do sine inverse of sine of theta equals sine inverse of 0.4. Right, I'm allowed to do that as long as I do it on both sides of the equation to keep my equation balanced. Just like if I had, x plus 5 equals 7. Right, well, if I want to solve for x, I have to do the inverse of plus 5, which is minus 5, right? And I have to, as long as I do that on both sides of the equation, it's okay. Well, the inverse of sine is the inverse sine function, right? The sine inverse, right? And over here, the sine inverse is going to cancel out, and I'm left with just theta. Just like over here, the plus 5 and the minus 5 cancel out, I'm left with just the x. Right, so I'm using the same principles of solving equations as I usually do. In order to get this theta by itself, I have to do the inverse of the sine function, which means I do the sine inverse on both sides of the equation, and that's going to cancel out the sine. So I get theta equals sine inverse of 0.4. Right, and now I can go to my calculator and type in sine inverse of 0.4 to get my answer. Now, remember, it's asking us for answers in degrees, so the first thing I do is check my mode screen and make sure that my calculator is in degree mode rather than radians, which mine is, so that's good. Whenever you're doing these problems now, you should always check your calculator, because some problems ask you for radians, some are in degrees. From one problem to the next, you might have to change the mode on your calculator, so it's always a good idea, especially if you just jumping in, this is the first problem you're doing, check your calculator to see what mode it's in, because the last problem you did might not match the one you're doing now. All right, so I'm in degree mode. I do sine inverse of 0.4, right? I type that in, and I hit enter, and I get 23.576. So let's round that to 23.6 degrees. All right, so theta equals 23.6 degrees. All right, so that's it. Well, that's not it. We've solved this equation. We got our angle theta, but it asked me to find all the angles between 0 degrees and 180 degrees, right? All angles, right? So 23.6, that is between 0 degrees and 180 degrees, but is that the only one between 0 and 180 where the sine of that angle equals 0.4? Maybe it is, maybe it's not. We have to check it out to see, right? And the way we check it out to see is we think about the definition of the trig function and what that really means. So let me draw a quick little diagram here in XY coordinate plane. Right, remember, when we're talking about degrees, 0 degrees is the positive x-axis. If my angle goes all the way over to the negative x-axis, that would be 180 degrees. All right? Now, my angle theta of 23.6 degrees is going to be somewhere up in here. Right, here's an angle of 23.6 degrees. And if this is in the unit circle, right? Which I'm not going to draw the unit circle, so this is going to make too much stuff on the board here. But if that's a terminal point on the unit circle, what this is saying is the y coordinate of that point is going to be 0.4. Right, so it's x comma 0.4. I don't know what the x coordinate is, and frankly, I don't care what the x coordinate is. Remember, the definition of the sine function in terms of the unit circle, the sine function gives you the y coordinate of your terminal point. So this is saying that for an angle of 23.6 degrees, if I put that in the unit circle, it's going to give me a terminal point where the y coordinate equals 0.4. All right, now the question is there another point between 0 degrees and 180 degrees? Is there another angle there where I'm going to have another y coordinate of 0.4? The answer is there absolutely is. If I move over here into the second quadrant, right, whatever this angle is, that kind of just reflects over, right, this point is going to have negative x comma 0.4. Right, the y coordinate is going to be the same because it's at that same level, that horizontal line there, and the x coordinate, when I flip it over to the second quadrant, it just makes the x coordinate negative. Right, and once again, I don't really care what the x coordinate is here. I could figure it out if I wanted to, but it's not really important to what we're doing. So there is going to be another angle between 0 and 180 that also has a y coordinate of 0.4. Right, so when you're doing the inverse sine function, you have to read really any of the inverse trig functions, you have to read the instructions carefully. Doesn't want just one single angle, doesn't want all the angles between two angles, like in this case between 0 and 180. And if it wants all of the angles between a certain values, once you find the first one, you got to make sure you look and see if there's any others. All right, now you might say, well, if there's another angle over here, why did my calculator only tell me the one? Why didn't my calculator give me two answers? And that goes back to the definition of the inverse sine function. Right? Remember, the inverse sine function only gives you numbers from the right half of the unit circle. It only gives you numbers between negative pi over 2 and positive pi over 2, or in degrees, between negative 90 degrees and positive 90 degrees. Right? The sine inverse is only going to give you an answer from that interval, from that right half of the unit circle. But there might be another angle over here that also solves this equation. Right? So we need to make sure that we take that into account. The inverse trig functions are only dealing with half of the unit circle. Right? The cosine is the top half. The sine and the tangent is just the right half. So if we're dealing with those functions, we need to check for other answers, right? Because as we've seen it, if you've been kind of following along with the other videos I've done about trigonometry, the points on the unit circle get reflected all over the place to all the other quadrants. So if there's one point here where sine is equal to 0.4, there is going to be another one. It's just a question of, is that other one in this range that they're asking me for between 0 and 180? And we can see that this one definitely is. Right, so now I got to figure out what is this angle. Right, from here, from the positive x-axis over to there, what is that angle measure where if I do the sine of that angle, I get 0.4, right, meaning it has a y coordinate of 0.4. Well, once again, we're going to use symmetry. If this angle over here is 23.6 degrees above the x-axis, this one over here is also 23.6 above the x-axis. Right, meaning if I do 180 degrees minus 23.6 degrees, that's going to give me that angle up there. Right? Again, we use symmetry all the time when we're doing trigonometry. Right? This one's 23.6 higher than 0. This one up here is 23.6 less than 180. Right? They're the same angle above the x-axis, just on opposite sides. Right? So if I do 180 minus 23.6, I get 156.4 degrees. Right, so theta also equals 156.4 degrees. Right, so there are actually two angles between 0 and 180 where the sine of that angle is going to equal 0.4 because there's 2 points on my unit circle where the y coordinate is going to be 0.4. One of them's in the first quadrant, the other one's in the second quadrant. Right, and just to kind of show you that this works out, if I do sine of 23.6 and then I also do sine of 156.4, right, notice that they both give me approximately 0.4. Right, so sine of both of those theta numbers gives me 0.4. They don't give me exactly 0.4 because I had to round the answers off, right? It wasn't exactly 23.6. It was like 23.57 something or 59, something like that. But if I plug both of those back in to check, they both solve that equation, which means I was correct in getting that other answer over there. All right, so that's solving a simple trig equation. Your calculator will give you one answer, but you always have to double check to see if there's another one in the range that you're being asked to find it. All right, I'm going to pause the recording here and do one more. That I think the next one's going to involve a cosine function. The next equation we're going to look at is cosine theta equals 0.4. All right, so I put up the first couple steps here. The first couple steps are just like that last example we did. All right, so I have cosine theta equals 0.4. I need to solve for theta, which means I need to cancel out the cosine, which means I do cosine inverse on both sides of the equation. On the left side over here, the cosine inverse cancels out the cosine, so I get theta equals cosine inverse of 0.4. All right, and then I can go to my calculator and type in cosine inverse of 0.4, and I get 66.4 approximately. All right, so my theta value, when I solve this equation, theta equals 66.4 degrees. All right, so that's my solution to that equation, or I should say that's a solution to this equation. It might not be the only solution. Remember, just like last time, we're asked to find all the angles between 0 degrees and 180 degrees. Right? 66.4 is between 0 and 180, but is that the only one between 0 and 180 where the cosine is going to equal 0.4? All right, well, I'm not sure. We need to check it out. We need to investigate to see that that's the case. All right, so the key thing for the first part is, when you're solving for that angle, the theta or the x or whatever it is inside the trig function, you have to do the inverse trig function to cancel out the original one. Don't just do cosine of 0.4, right? It's cosine inverse of 0.4 to get your answer. Right, but once we do that, if I kind of draw a little unit circle over here like I did before for the last one, and let me make this a little darker so it's easier for you all to see it. All right, so 66.4 degrees. That's going to be somewhere up in here. All right, there's my angle of 66.4 degrees. And since the cosine of that angle is going to equal 0.4, that means that for my my terminal point, the coordinates are going to be 0.4 comma y, right? My x is 0.4. Because remember, the definition of the cosine function is the cosine function gives you the x coordinate of your terminal point on the unit circle. Right now, we're looking for, once again, all the answers between 0 and 180. All right, so all the answers up top here. Well, is there another point between 0 and 180 where my cosine is going to equal 0.4, where my x coordinate is going to be 0.4? And in this case, there's actually not. Right? There is another point on the coordinate plane or on the unit circle where the x coordinate is going to be positive 0.4, but that's going to be down here in the fourth quadrant. Right? For x to stay positive 0.4, I would have to reflect that point downward to the fourth quadrant. That's going to have the coordinate 0.4 comma negative y. Right? Remember, the one for sine, since sine was the y coordinate, I had to reflect it over to the second quadrant to have that same y coordinate. When I'm dealing with cosine now, since cosine is the x coordinate, I take that point from the first quadrant, I have to reflect that down into the fourth quadrant in order for it to have that same positive 0.4, that same x coordinate. Right? And this point down here, or this angle here that goes all the way around like this, that's not between 0 degrees and 180 degrees, right? So in this case, if I'm looking for all the angles between 0 and 180, this is the only one, 66.4 degrees. That's the whole story, right? Now, if this had been worded differently, if this had said find all angles between 0 and 360 degrees, well then, this angle is between 0 and 360, right? Because 360 is all the way around, one full lap around the circle. So if it said 0 to 360, I would then have a second answer here that I would have to figure out what this angle is and then give that as one of my answers, right? So again, read the instructions for the problems carefully. Some problems just say, find one angle that solves this equation, in which case once you find the first angle you're done. Some of them say between 0 and 180, some might say between 0 and 360, and if it says between 0 and 360, you're going to have two answers pretty much all the time. But if it says between 0 and 180, you can see with the sine function we got two answers, with the cosine function we really only got one. And the reason we only have one here is because, remember, for the cosine inverse function, that's giving us stuff from the top half of the unit circle, right, between 0 and pi, or between 0 and 180. So when we're looking for 0 to 180 and we do cosine inverse, it's giving us the only possible answer, right? The other answer is not between 0 and 180. It's down on that bottom half of the unit circle, which in this case we're not concerned with, right? So read the problems carefully. Make sure you look for those extra answers if they may exist. And make sure you're using the inverse trig functions on those numbers in order to get your solutions when you're solving the trig equations.